Assalamualaikum warahmatullahi wabarakatuh. My name is Mama Ashraf, and before this video begins, let me ask you, what do you know about RAID? Well, we have heard the word RAID many times. For instance, as this RAID, or maybe this kind of RAID. But we all don't know the meaning of the real RAID, which is this RAID. So today, me and also my team members, my group project members, are going to present about rate, which is our main topic focus of our project. Okay, so let us begin.
Okay, so let's start with a brief introduction of our project. For our project, which we choose is RAID, we made a life size model of RAID actually. Like we stack up a bunch of polystrenes and also some manila cut together so that it forms the RAID system that we know until now. The RAID in our project includes RAID 1, RAID 3, RAID 5, RAID 6, and also RAID 10. This project took us at least I think 5 to 6 days or maybe a week if I'm not mistaken. We did this during our free time, but we did it at KICT so that we all gather gather there and also do the project at the same time. Everybody helped out. No one was left behind. Everybody contributed in the project, and also we are happy with what the outcome has given us. So this is the final outcome of our project. As you can see, it's actually kind of messy because we just finished. But don't worry, we cleaned up all the messes that we made, and also we got the broom and stick so that there isn't any polystyrene left on the floor. So this is what our final looks like, and honestly, we are pretty happy about it. So this is our group members. Unfortunately, one of the group members, Ubaid, can't contribute in the last part because he has an examination on that day. But he did help us previously on the labeling and also the okay. So this is what the last and also the final product look like. Final model look like actually. And as you can see, there is the rate 1, rate 3, rate 5, rate 10, and also rate 6. So this project has actually give us many experiences. And yes, I know since we are KICT, this is not very KICT like because we are making a full scale a model out of our project. But since we have no more ideas or maybe brainstorming, so we just went through this, and it actually had for us it's been a big learning experience and help us bond as team members. Okay, so what is RAID? RAID, or also known as redundant array of independent disk, is a way of storing the same data in different places on multiple hard disks or solid state drives, such as SSDs, to protect data in case of drive failure. There are different RAID levels, however, not all of them share the same goal of providing redundancy. RAID works by placing data on multiple disks and allowing input or output I/O operations to overlap in a balanced way, improving performance. Because using multiple disks increase the mean time between failures, storing data redundantly, and also increase fault tolerance. Okay, I will be explaining about RAID 1 and also RAID 3. Let's move on to RAID 1 first. Okay, so RAID 1, also known as disk mirroring, is the replication of data to two or more disks. Data mirroring is a good choice of application that require high performance and high availability, such as transactional application, email, and operating system. When you want to store critical data and sensitive data, RAID 1 is the best choice as it mirrors data on two disks. Or so even if there is a problem with the primary disk, you can always retrieve the content from the second one. In general, RAID 1 is a good choice of data redundancy and is a good key feature of your storage needs. Okay, let's move on to RAID 3. Okay, so RAID 3 is a RAID configuration that uses a parity disk to store the information generated by a RAID controller instead of stripping it with the data. Because the parity information is on a separate disk, RAID 3 does not perform well when tasked with numerous small data requests. Because RAID 3 combines parity and stripping with stored data bits on a dedicated disk, this configuration requires at least three separate hard disks, two for stripping data and one for storing parity bits. The disk must spin in sync, so sequentially read and write RW operations achieve good performance. However, random RW read and write operators may take heavy hits in performance.
Assalamualaikum everyone, I'm Sakawi and today I'll be talking about RAID 5. So, what is RAID 5? RAID 5 is a redundant array of independent disk configuration that uses disk striping with parity. Data and parity are stored evenly across all over the disk, so no single disk is a bottleneck. Striping also enables users to reconstruct data in case of a disk failure. RAID 5 evenly balances risk errors and is currently one of the most commonly used RAID methods. It has more usable storage than RAID 1 RAID 10 configurations and provides performance equivalent to RAID 0. RAID 5 have a minimum of 3 HDDs and no maximum because the parity data is spread across all over the drives. RAID 5 is considered one of the most secure RAID configurations. And how does it work? The benefit of RAID 5 come from its combined use of this striping and parity. Striping is the process of storing consecutive segments of data across different storage devices. It enables better throughput and performance. This striping alone does not make an array fault tolerant, however, this striping combined with parity provides RAID 5 with redundancy and reliability. RAID 5 uses parity instead of mirroring for data redundancy. When data is written to a RAID 5, the system calculates parity and writes that parity into the drive, while mirroring maintains multiple copies of data in each volume to use in case of failure. RAID 5 carry build a failed drive using the parity which is not kept on a fixed single drive. By keeping the data on each drive, any two drives can combine to equal the data stored on the third drive, keeping the data secure in case of a single drive failure. And also, drives can be hot swapped in RAID 5, which means a failed HDD can be removed and replaced without downtime. What what is the advantages of RAID 5? Fast, reliable read speed is a major benefit. It also offers inexpensive data redundancy and fault tolerance. However, writes tend to be slower because of the parity data calculation, but users can access and read data even while a failed drive is being rebuilt. And also, RAID 5 is ideal for application and file servers with a limited number of drives. And so, what is the disadvantages of RAID 5? Because of the parity, longer rebuild times are one of the major drawbacks of RAID 5, and this delay could result in data loss. Because of its complexity, RAID 5 rebuilds can take a day or longer depending on controller speed and workload. If another disk fails during the rebuild, then users lose the data forever. Additionally, while the backup provided by RAID configurations can contribute to business continuity, they are not equivalent to a disaster recovery setup in which hardware is both on and off. promises. And so that's all from me. So I'll pass to the next presenter. Thank you.
So, Bismillahirrahmanirrahim. My name is Muhammad Izan bin Suhaimi, 2120307, and I will explain about the RAID 10. Okay, RAID 10 is a configuration of RAID that provides both redundancy and performance, making ideal for I/O intensive applications such as email, web servers, and databases. The name RAID 10 itself translates quite literally to its configuration, which combines this mirroring, RAID layer 1, and this striping, RAID 0. This mirroring is the replication of data on two or more disks, providing instantaneous failover for mission critical applications. This striping, on the other hand, divides a body of data into blocks and spreads them across multiple storage devices, resulting in faster read and write times. By nesting these two layers in this order, RAID 10 provides lower latency and superior throughput compared lower latency and superior throughput compared to most of other RAID levels and nestings. However, because this RAID 10 mirrors the dataset before striping, it has reduced capacity compared to the other RAIDs levels with 50% less capacity due to having two sets of the same data. So that's all from me. Thank you. We move.
Assalamu alaikum warahmatullahi wabarakatuh. So now I'm gonna talk about redundant array of independent disks level 6 or RAID 6. So RAID 6 is very similar to RAID 5. It uses the same concepts of data striping and data parity across all the disks. However, there are some differences between the two. As we can see from the given diagram, RAID 6 requires at least 4 disks to work. It is very similar to RAID 5, but it extends the RAID 5 by adding another parity. That is, RAID 5 only uses a single parity across the disks. In case of RAID 6, it uses dual parities across all the disks, which are striped separately. It provides us an advantage by giving us protection in case of a dual drive failure. We can see in this video that in case of a dual drive failure, we can use to reconstruct the data into two new hard disks with the help of the data parities that are available in the previous hard disks. So by this way, it provides a protection against a dual drive failure. However, there is a disadvantage of RAID 6 too. Due to the extra parity calculation in case of a drive failure, it overall hinders the performance of the disks. So, in summary, RAID 6 requires 4 disks, it uses dual parities across all the disks, it provides an advantage of protection against a dual drive failure. The only disadvantage is that it shows a hindrance in the overall performance.